So far we've looked at a number of different ways to name alkanes, alkenes, and alkynes. Basically, any organic material that is made purely out of carbon and hydrogen. But that's not the only stuff that organic material is made out of. Organic material is based around carbon, but we also have oxygen involved, we also have nitrogen, and various other compounds. And depending on how they attach and how they connect, it can completely change how a molecule functions. Let's look at a couple hydrocarbons before we start looking at this phenomenon. First, let's look at something like this. We should be able to name this. We've got our first step of just numbering our hydrocarbons. I've got a constituent coming out of the middle. The other two are the same thing on either side. So it doesn't really matter which direction I name this from. So I'm just going to count it. 6, 7. So that's 7 carbons long. Well, it's going to be hept. Now, notice I've got double bonds here, but those aren't on my main chain. So this is still heptane. Okay? But it does have these constituents. On the 4 carbon, I've got a 1, 2. That's going to be an ethyl group. So I'm going to have a 2-ethyl. And then on the 3 and the 5, I've got 2 methyl groups. But let's go 3, 5, dimethyl. But those both have double bonds. How do I name that? How do I put a name onto that? Well, for this particular instance, I still just follow my normal naming conventions. When I have a double bond, I've got an N suffix. If I've got a side chain, I've got an il suffix. The il is going to beat out the N. So I can just call this dimeth-N-il. So the logic of these names really kind of holds up. We're just able to throw these numbers at it and make it make sense. So if we write out the whole thing, remembering that E becomes before M, so I've got 2-ethyl, 3, 5, dimethyl. Notice the D does not come before the E, the di, the tri, none of that matters. It only matters the M, the constituent's numbered name. So 3,5-dimethyl, nope, that's meth-N-il. Heptane. So we're able to make a very complex name from a fairly complex molecule. Okay. How about this next one? Well, this one clearly has some earlier constituents. So I'm going to name it, I'm going to number it from the right to the left. So it's going to be a 1, a 2, 3, 4, 5, 6, 7, and 8. Okay? Let's make our 8 a little more like an 8 there. Good enough. So this is going to be an oct, and then it's got a double bond here at the 1 carbon. So this is going to be oct 1-ene. Okay. Now what are my side chains? Well, first at the number 2, I've got 2-methyl. So I've got 2-methyl. What else? At the 3, I've got a 1-2, an eth-N-il. So at the 3, I've got an eth-N-il. N for the double bond, il for the side chain, F for the 2 carbons. Okay, that all makes sense. And now number 5, I've got a, wait a minute, what is this? Is this a 1, 2, 3 chain with another 1 chain off of it? It's not. We still name this based on how many carbons are in the side chain. This is a side chain because it's to the side of the main chain. It's got fewer carbons in it. So a 1, 2, 3, 4 carbon chain, this is going to be a butyl group. There used to be all kinds of custom names for the more common side chains that connected on a middle carbon. But now we've generalized those. The IUPAC has generalized that numbering system to just say this is a 5-butyl, so 5-butyl, but the il, since that's where the side chain connects, we're going to number that carbon. So this bute gets a 1, 2, 3, 4. Since the 2 carbon on the butyl chain is where it connects, I'm just going to write in a but 2 ill. Now this is a little more rare, but you will see it. You will need to be able to name that. So this 2 gets put in for the ill. If we've got a 1, if it connects on the 1 carbon, that's so common we don't bother writing it in. So I don't need to start going FN1 ill. It's just ethanol. Good enough. Okay? So this, if I put everything in alphabetical order, B before E before M, I've got a 5 but 2 ill 3 F N ill, and I really should be numbering where that N is. That's going to be a 1, 2. So that F1 N ill 2 methyl, almost off the page, oct 1 ene. What a mouthful. 5 but 2 ill 3 F 1 N ill 2 methyl oct 1 ene. A complex name, but it describes the structure. Great. What about this? It's a much simpler compound, but we haven't learned about this yet. Well, this is called an alcohol. Whenever I have a carbon chain that has an OH group sticking off the side of it, if we really drew this out, this would look like, I'm going to zoom in right here. This would look like I've got a carbon. So I've got a carbon connecting up to another carbon here, connecting up to another carbon here, connecting up to a hydrogen here, but down it's going to a O, going to an H. Whenever I have this situation right here, this OH that is sticking off, whenever I have this situation right here, this OH that is sticking off of a carbon on a carbon chain, we call that an alcohol. An alcohol is one of many types of functional groups. We call these functional groups because it's a group hanging off of a carbon chain that produces a specific function. Now, the alcohol here, what this provides that carbon chain with is hydrogen binding. So suddenly, I'm able to have hydrogen binding where normally I would have only had London dispersion forces. This can allow this to interact with a large number of different types of molecules that it wasn't able to before, and it's going to drastically change some of its physical properties. For example, methane versus methanol, the alcohol of methane, which just has an oxygen attached to one of the hydrogens. That is a liquid at room temperature. It's very flammable, but it burns at a much lower temperature than methane. So it has these very distinct chemical properties that separate it. So let's look at what I mean by different functional groups. Let's take a look at a list. We're going to be making a list here. And on this list, we're going to have 8 different functional groups, all with a different level of priority. These all get different priorities of naming conventions. So the first one we're going to look at is the alcohol. Alcohol is number 5 on our priority. And whenever I'm naming something with an alcohol, all I'm going to do, if alcohol is the highest priority, if I don't have any of these first 4, which we'll get to, then alcohol is going to give it a new suffix. These are always going to give it a suffix if they can. And that suffix is going to be just the ending -all. So for example, if methane has an alcohol group, it becomes methanol. If ethene had an alcohol group, it would become Ethanol. Okay? And just like we normally name these with a number, telling us where that functional group is, we're going to do the same thing here. So let's just draw an ethene with an alcohol on it. So eth is normally 2, ene means double bond, and then I'm going to give it an OH. Now clearly, there's only one place that can go. If I'm going to number this appropriately, I would call this the number 1 carbon, this the number 2. Be careful when drawing these. I do not have a carbon at this point right here. This connection only signifies the bond to the oxygen. My first carbon is here, my second carbon is here, my alcohol is here. If I flip this molecule around, it would look like this. And I would still call it the same thing. 1 and 2, it would be FN1-ol. So I can really just say ethanol because there's no other option. But if we look at some more complex versions of this, it'll change slightly. Here we have 4 compounds that all have that OH subgroup on them. First, let's name this one. Remembering, we're going to name starting from our, so that our constituent has the lowest possible number. This is going to be a 1, 2, 3, 4, and 5. This is going to be a pent, no double bonds, and OH on the 2, 2-ol. Simple enough. Next one, I've got a 1. Remember, this is my carbon. This right here is not a carbon. 2, 3, 4. So this is bute. There's no double bond, so it's an 1-ol. Standard procedure is to drop the 1 for a functional group. We're just going to leave it in there for simplicity's sake, just for consistency. Here I've got a 1, 2, 3, 4, 5 carbon chain. And notice I've got 2 OHs. It doesn't matter if I number it from this way or this way. They'll take the same spots, but it works just like it would if I was naming an alkene or if I had 2 methyl groups. I'm going to use that diol. So 5 is pent. No double bonds, so it's an. And then it's going to be 2 and 4, 2, 4, diol. There we go. So our naming conventions hold up, just adding in this new suffix of ol. So now let's mix that with some of our side chains. So this guy, let's look at it this way. Well, I've got a longer side chain here, so I'm going to go 1, 2, 3, 4, 5. But if I look at it this way, this side chain is actually going to be longer than this one. So actually, I'm going to start naming it. I have to number from that direction. Now that's actually going to put my alcohol at a lower number counting from this way. So I'm going to need to do that. So 1, 2, 3, 4, 5, 6, 7. Okay, there we go. To show you what I mean by that, if I numbered it the other way, if I went 1, 2, 3, 4, 5, 6, 7, suddenly my alcohol is on the 5 carbon. Well, that can't work. It's got a higher priority. Let's come back to that in just a minute. So let's give this a name, and then let's talk about that higher priority. So I've got 7, that's hept. No double bonds, that's an. And then alcohol on the 3. Heptan 3-ol. But then I've got on the 2 carbon a methyl group. And on the 1, 2, 3, 4 carbon, another methyl group. So 2,4-dimethyl. Heptan 3-ol. Okay, there we go. Now let's look at that priority structure. Because we're introducing alcohol, however, we do already have some of these functional groups. Specifically one of them. The seventh priority here is going to be an alkene/alkyne. With the alkyne technically taking higher priority. There is no prefix for alkenes or alkynes. There's only the suffix "-n" and "-ine". Okay? So whenever I'm counting these carbon chains, if I see an alcohol group and an alkene or an alkyne, or if I see a side chain, let's see, side chain priority. Let's actually put a 9 here. Side chain priority is actually going to be the lowest possible priority because they don't have a suffix. They always have a prefix. So they kind of don't count. So when we're looking at these functional groups that we already have figured out, we have alkenes and alkynes, which will always get a suffix of "-n" and "-ine". In fact, if something else goes over the top, like the "-ol", the alcohol, then I go "-n-ol" or "-ine-ol". Okay? So there's no way for this to have a prefix. Likewise, the side chain, just a regular hydrocarbon side chain, is going to have the lowest priority. It's just going to get that regular prefix, the meth, eth, prop, but, and then it's going to get its own custom suffix of "-il, and it's just going to be tacked onto the front of our name. We've already talked about that, but this priority comes into play in two ways. One, in how we number our carbons. The highest priority gets preference over how the carbons are numbered. So remember, when we number our carbons, we're trying to give that highest priority functional group the lowest number carbon it can have. Okay? That might take a little bit of getting used to. The second thing is prefixes and suffixes. Now we can have a very diverse number of functional groups. Even these 9 that we're looking at aren't all of them. And a lot of them will have a prefix and a suffix possible. So if we have one of these first 4 that we haven't looked at yet, as well as an alcohol, one of these first 4 would get the priority numbering and the priority naming, and would give it that suffix, and instead we would give the alcohol a prefix. We're going to see examples of that, so right now all I'm giving you is the name of the prefix, which for an alcohol is hydroxy. And this will get tacked on just like a side chain would. But once we get into examples that include more of these more complex functional groups, we'll be able to see how that naming structure kind of shakes out. For now, we've seen some examples of alcohols competing with side chains. Let's take a look at some examples of alcohols competing with alkenes and alkynes. Here I have 2 examples of having both an alcohol functional group and an alkene/alkyne. The first one has an alkene. I'm going to number this carbon chain. I'm going to number it from the alcohol because the alcohol has a higher priority. So we go 1, 2, 3, 4, 5. So this gets the name pent. And since it's an alkene, since it has that double bond, it's got that N suffix. It still has that. But we need to give that the number 4. So 4N. And then the alcohol gets that number 1. That's because the alcohol has a higher priority. So this is the correct name. Now let's look at the incorrect name to see why does it matter to have a priority? Why does this priority matter? Well, I wouldn't name this pent, numbering the other way, pent 1N5-ol. This would be incorrect. This would be incorrect because it doesn't take into account the alcohol's higher priority. So this is wrong. So we see there's two ways to name this. We have to pick one. Which one is right? Well, we give the alcohol a higher priority, so that one is right. And likewise, for this guy, we're going to count our numbering chain. The alcohol gets a higher priority, so we go 1, 2, 3, 4, 5, and 6. So this is going to be hex. And I've got a double bond and a triple bond. My double bond starts on 3, hex 3, N. My triple bond starts on 5, 5, ein. My alcohol is on 1, 1, all. So we have the N on the 3, the ein on the 5, because the alcohol has that higher priority. Okay? Next, we're going to take a look at some more different types of functional groups.